Hello guys, how are you? कैसा है बच्चे लोग? This is your KP sir on YouTube again. So myself Krishna Prakash. Students love to call me KP sir or EE sir. I have 16 years of teaching experience, trained more than 150 batches, and worked in all top coaching centers in India. Now in an academy online platform, I am going to teach environmental engineering, hydrology, irrigation, construction materials and open channel flow. So if you want to watch my free classes on an academy, you just search NVLK Prakash. You will get my free classes, watch the lectures, and if you want to join plus course, paid full length course of GATE and ESE, use the code KPCivil. You will get maximum discount and all the benefits provided for you. Use the code, don't forget what is the code? KPCivil. Use the code KPCivil, then take plus subscription. You will enjoy all the benefits. You will enjoy the full length GATE and ESE subjects. So before going to start the session, just a small announcement. In an academy, we are providing various free online tests. In that, this is an online competition. Most expected questions for GATE 2021. Very important. Most expected questions for GATE 2021. Free test series for any one of the student who is appearing for GATE aspirant. And along with providing free test series, we are giving you surprise gifts. Win the prizes worth 6 lakhs. You can win the prizes worth 6 lakhs. So 3 series of tests. 14th November test 1 already completed. 21st November test 2 on strength of material, structural analysis, RCC, steel and open channel flow. 28th November test 3 construction management, building material, fluid mechanics and transportation engineering. So what are the benefits you are getting? First of all, you get good subject knowledge. You are going to expose to subject oriented basic questions, very important questions, most repeated questions. So you are gaining knowledge. Anyway, while writing any online test series, you are gaining knowledge. Very importantly, it is a free test series. You are not paying anything for this test series. It is a free test series. And you will get rewards. For those who got first 1 to 5 ranks, you will be rewarded with 2,000 rupees. 6 to 10 ranks 1500, 11 to 25 ranks 1000. So like that, for each branch 3 topic wise test series conducted in 3 parts we have given here. Part test 1, test 2, test 3. You are going to getting benefited learning subject knowledge. Along with that, you are getting prizes rewarded for your benefit. Okay, enroll now for the test series as early as possible. And also ISRO Revise India syllabus. ISRO Revise India series as per the recent syllabus of ISRO. Free previous year question sessions and all India ISRO mock test for all branches, mechanical, electrical, civil, EC, CS and IT for all branches. All India series ISRO mock test from 7th to 21st November. 7th to 21st November, free PYQ classes going on. Free PYQ classes going on in an academy. Then test is conducted on 22nd November. Again, win exciting prizes worth 3 lakhs. Enroll now itself. Enroll now itself. So, from an academy end, we are ready to support each and every student. Remember, not only for paid subscribed student, for each and every student who are unable to afford the prizes, we are providing free classes, we are providing free online test series, along with exciting rewarding prizes also. Everything we provide. The only thing from your end, you spend your time, write the exam, get rewarded with the exams. Okay, let's crack it. And one more announcement. From 20th November, we are going to start Spark ESE 2021 prelims batch, 7 months batch, in which myself, Rajendra Prasad sir and Praveen Kulkarni sir will teach all civil engineering subjects, core civil engineering subjects. We will take care. So take your plus subscription as early as possible using the code KPCivil. What is today's session? Today's session is related to 2017 GATE previous year questions PYQ. 2017 GATE PYQs for civil engineering, engineering hydrology, from the subject engineering hydrology. We will discuss both set 1 and set 2 questions. In detail, we will talk about solution, how we are getting solution. I am going to analyze each and every stepwise manner. I will explain you. Let's enjoy the topic.
Hey, I will challenge you in PUBG. Will you come online to play?
No, I have online GATE class. I don't want to miss it.
Who is teaching?
Top faculty of civil engineering in India, KPCivil on an academy. I am a big fan of his teachings.
Oh yes, I have also heard about KPCivil. I am willing to join the class.
It's nice. Take subscription in an academy using KPCivil code. You will be benefited more. Okay, let's crack it.
Now first question. A catchment is idealized as a 25 kilometer by 25 kilometer square. Square shaped catchment. Given here, diagram. Square shaped catchment, 25 kilometer square. So what is the total area of catchment now? From the first sentence itself, we'll write down total area of catchment. 25 into 25, no, it is a square area. 25 into 25 we can take 625 kilometer square. 625 kilometer square. It has 5 rain gauges, 1 at each corner, 5 rain gauges, 1 at each corner and 1 at the center. So it was shown here in the figure. Each corner carrying gauge 1 Z1, gauge 2 Z2, gauge 3 Z3, gauge 4 Z4, and in the center one more gauge G5. During a month, the mean precipitation, the precipitation at these gauges is measured as G1 300 mm, Z2 285 mm, Z3 272 mm, Z4 290 mm, Z5 288 mm. Okay. Now, the average precipitation over the catchment during this month by using Thiessen polygon method. Using Thiessen polygon method, we need to estimate average precipitation. So, if you need Thiessen polygonal method, average precipitation formula. What is formula for average precipitation? It is weighted average of. It is weighted average of precipitation and area P1A1 plus P2A2 plus P3A3 and so on, PNAN divided by total area. A1 plus A2 plus A3 and so on divided by total area AN. This is weighted average of precipitation and individual area that was taken as weighted average, Thiessen polygonal method. So for this, what you need? You need to know individual area. Consider this is the square you are having. Now you need to know individual area. So here center there is 1 rain gauge. 4 places 4 rain gauges are there. 4 locations 4 rain gauges are there. And at the center one more rain gauge is there. So I am going to draw according to Thiessen polygonal method. I am going to draw perpendicular bisectors from the central rain gauge. So these are the perpendicular bisectors drawn from the central rain gauge. Okay. These are perpendicular bisectors drawn from central rain gauge. So this is the location of central rain gauge. Now I am connecting the 4 points of location of central rain gauge. 4 points of center of central rain gauge, because we need to know the area covered by central rain gauge. So this central rain gauge is going to cover the area. This is the area covered by central rain gauge. Clearly I have drawn. Observe it carefully. This is the area covered by central rain gauge. From all 4 sides it is covering the area. So this is the area covered by central rain gauge G5. Now what is area covered by A1? Rain gauge 1. Area covered by rain gauge 1. I am going to take this. Area covered by rain gauge 1. This complete I will consider. A1, area covered by rain gauge 1. Now, what is area covered by rain gauge 2? I am taking this one. Okay, this is area covered by rain gauge 2. Maybe rain gauge 3, okay. This is another area. Like that 4 areas are available here now. 4 areas we are having here now. This is area 3. This is area 3. We have one more area here. Area 4. Total 4 areas now. Total 4 areas now. I will give numbers. 1, 2, 3, 4. 4 triangular areas I am taking. You understand? I have divided the total area into 4 triangular areas. I am dividing total into 4 triangular regions of same area. We'll take it. A1 is equal to A2 is equal to A3 is equal to A4. All are having same now, because it is a square. All are having a square. So it is a total now, all are having same area because it is a square. I am taking here this total is side is 25 kilometer. 25 kilometer. So what is this base now? This base is 12.5. This base is 12.5. Same here also we will take this height as 12.5. This height also 12.5. It's not it. So we will take here A1 is equal to A2 is equal to A3 is equal to A4. What is the area formula? Half BH. Half into B. 12.5 H. 12.5. Tell me. Half into 12.5 into 12.5. Tell me. Area of triangles we are considering now. Half BH, half into 12.5 into 12.5. So how much you are getting now? Area of triangle here? 78.125 kilometer square. 78.125 kilometer square. Now what is the area covered by this? This one is there na A5. What about A5? Fifth rain gauge. Area covered by fifth rain gauge we can write down. Area covered by fifth rain gauge is equal to, I am writing total catchment area minus total area by 4 triangles. Total area by 4 triangles. We need the area for A5. This area is needed. So total area already we estimated 625 kilometers square. Each triangle, total 4 triangles, each triangle 78.125. So we'll get the area of 5th rain gauge station. Area covered by 5th rain gauge station you will get now. 4 triangular areas you got A1, A2, A3, A4, each of 78.125. So for A5, what you are getting? Calculate it. 625 minus 4 into 78.125. 625 minus 4 into 78.125. 312 kilometers square. 312 kilometers square. That is A5. All areas obtained. All areas obtained. All precipitation values are there. All areas obtained. All precipitation values are there. Now, we'll go for average precipitation. According to Thiessen polygonal method, average precipitation. All 4 triangles are carrying same area. So first I will add precipitation values of 4. A1, A2, A3, A4 same. So just I am adding precipitation values. 300, 285, 272, 290. 300 plus second rain gas. 285 plus third rain gas. 272 plus 290. Each precipitation is represented by same common area. You understand the point? Each precipitation is represented by same common area 78.125. So 300 plus 285 plus 272 plus 290 into 78.125 plus what is A5? P5. P5 is 288. P5 is 288 plus 288 into 600. What is A5? What is A5? Calculated na 312. A5 is calculated na 312. So 288 into 312. This is P1A1 plus P2A2 plus P3A3 plus P4A4 plus P5A5. Instead of taking individual, because all 4 are carrying same area, first 4 precipitation values sum into their area plus A5 into P5 divided by what is total area? We know it na, total area 625 kilometers square. So this is easy. Knowing areas is only important. Remaining question is very simple. You are getting 287.3 mm. This is your answer. 287.3 mm. That is your answer. Just you need to know how to derive areas. How to derive areas. I will make it very simple. If this kind of model related to Thiessen polygon means one diagram is provided, individual precipitation, individual areas given, you want to determine average precipitation by Thiessen polygon. I have a simple sweet cut formula. What is sweet cut? Shortcut. Take arithmetic average. Even you are doing arithmetic average also, you are getting same answer. Not new. Not new. Show. Check here. If you have doubt, check here. 300 plus 285 plus 272 plus 290 plus 288 divided by 5. 5 only the total rain gases divided by 5 total rain gases. Simple, easy answer. 287. They gave this answer 287 because in the exam they gave the answer between 286.9 to 287.9. They gave the answer. So you can give 287, no problem, because it will save your time now. Instead of doing this many area calculations after A1, A2, A3, A4 determination, calculation of areas, calculation of A5, then Thiessen polygonal determination. Simple mean arithmetic average gave the answer within the range. Okay, you can do any method, no problem, you will get the answer. So that is what I promised you. For each and every question I promised you to give shortcut formulas so that your GATE exam will become simplified. That is my experience.
Hey, I will challenge you in PUBG. Will you come online to play?
No, I have online GATE class. I don't want to miss it.
Who is teaching?
Top faculty of Civil Engineering in India, KPCivil on an academy. I am a big fan of his teachings.
Oh, yes. I have also heard about KPCivil. I am willing to join the class.
It's nice. Take subscription in an academy. Using KPCivil code, you will be benefited more. Okay, let's crack it.
Now, the infiltration capacity of a soil follows Horton's exponential equation. F is equal to C1 plus C2 into e power minus KT. So F is equal to, we have general Horton's equation. Ft is equal to Fc plus F0 minus Fc into e power minus KT. Just they gave here in place of Fc C1, in place of F0 minus Fc C2. Just to confuse you, nothing is there. Just to confuse the students, they gave this. Ft is equal to Fc plus F0 minus Fc into e power minus KT. During an experiment, the initial infiltration capacity observed to be 200 mm per hour. What is initial? F0. Initial infiltration capacity is observed to be, F0 is observed to be 200 mm per hour. After a long time, infiltration capacity was reduced to 25 mm per hour. So after long time means it is going to attain the steady state. Time is not mentioned. No worries. You consider after long time they mentioned. Take it directly as Fc. Steady state is attained. Steady state infiltration capacity, you take it 25 mm per hour. If the infiltration capacity after 1 hour, means you consider F1. F1 is equal to 90 mm per hour. The value of decay rate constant, Horton's rate constant, actually this is the value of Horton's rate constant, K is equal to. So it is very simple. They only provided the equation to you. Ft is equal to Fc plus F0 minus Fc into e power minus KT. Fc given 25, F0 given 200, time, what is time? Time is equal to 1 hour. Ft provided, Ft is equal to F1 90. Just substitution in the formula only. Anything difficult in this question for you? No, nothing. You take here 90 is equal to Fc 25 plus F0 minus Fc 200 minus 25, 200 minus 25. Fc is equal to, sorry, Ft is equal to, Ft 90 is equal to Fc 25, F0 200 minus Fc 25, e power minus k into 1 k1, e power minus k into 1 k1. So how can we solve this now? How can we solve this now? Tell me. K is required. I am writing K is equal to K is equal to ln. I'm bringing this 25 here. ln 90 minus 25 divided by 175. No? 200 minus 25, 175. So ln 90 minus 25 by 175. So what can I write down now here? 0.99 per hour. 0.99 per hour. Question also given to determine in per hour. So what is the value of K? 0.99 per hour value of K. Just you know Harton's equation, substitute it, you got the answer. Simple. You know Harton's equation, substitute it, you got the answer. We'll move on. Completed writing? During a storm event, in a certain period, rainfall intensity I 3.5 centimeter per hour. Rainfall intensity 3.5 centimeter per hour. And the phi index is 1.5 centimeter per hour. Phi value. Phi value is 1.5 centimeter per hour. Intensity of effective rainfall, same units in centimeter per hour for this period. What is effective rainfall? Intensity of effective rainfall is equal to runoff intensity. Runoff intensity. So I am going to write down runoff intensity as R. Ri. I will take Ri, runoff intensity. Why? Because we have the formula. No? Do you remember? Do you remember we have the formula for phi index? Phi is equal to P minus R by T. P minus R by T. P by T is intensity. So we write down phi is equal to I. R by T is Ri. So you need Ri. What you can get now? Ri is equal to I minus phi. You take it now. Runoff intensity, effective rainfall intensity. Runoff intensity, effective rainfall intensity, I minus phi. Any difficulty? Subtraction. Just subtraction. Just you need to subtract it. Nothing is there. Intensity of effective rainfall 3.5 minus 2.5. 3.5 minus 1.5. What you are getting now? 2 centimeter per hour. This is answer. Very simple. You write down here answer 2. Only subtraction. Given two values, subtract the values. 3.5 minus 1.5, you got 2. The basis is our regular formula, phi index. If you know this, you will have one compulsory mandatory question in GATE exam. Phi is equal to P minus R by T. From this only we have derived this. Okay? Done? Simple. Rainfall intensity minus phi index. Effective rainfall intensity. The ordinates of a 2-hour unit hydrograph. So check this. Every time without hydrograph question, we don't have questions from hydrology. Remember this. Without infiltration, without hydrograph, mostly we don't have hydrology questions. The ordinates of a 2-hour unit hydrograph for a catchment given there. Time 0, 1, 2, 3, 4. Ordinates 0, 5, 12, 25, 41. The ordinate of a 4-hour unit hydrograph for the catchment at a time of 3 hours. So I can write down we make a table here. Time 0, 1, 2, 3, 4. Given is 2 hour unit hydrograph ordinates. What are ordinates? What are 2 hour unit hydrograph ordinates? 0, 5, 0, 5, 12, 25, 41. 12, 25, 41. Now you need 4 hour UH. Na? Just what is going to determine is 2 hour unit hydrograph to 4 hour unit hydrograph. 2 hour unit hydrograph to 4 hour unit hydrograph. What is that? You are following method of superposition. You just follow method of superposition. Your work is completed now. Means just you plot a graph. I'm simply easily explaining you with example of graph regarding method of superposition. Discharge versus time. Consider there is a rainfall occurred 0 to 4 hours. It is happened like this. 2 hour. This is a 2 hour unit hydrograph. 2 hour. Another same 2 hour rainfall occurred after a second hour. That is resulting like this now. So you combine both. If you combine both, you will get 2 hour DRH. Sorry, 4 hour DRH. First one is 2 hour UH. Second one is 2 hour UH. You are just delaying 0, 1, 2, 3. Like that you are taking just delaying. So you are delaying the values. You are having values here 4. Maybe you are continuing the values. Same values after delaying 2 hours. Your total rainfall is 0 to 4 hours. I am dividing into 2 storms. Storm 1 between 0 to 2 hours. Storm 2 between 2 to 4 hours. Storm 1 resulted discharge from 0th hour. Storm 2 resulted discharge when? From 3rd hour. Storm 2 is going to show discharge from 3rd hour. That is what? So I will consider this is discharge values of storm 1. Given data. 2 hour unit hydrograph given data is discharge values of storm 1. Then storm 2 unit hydrograph data I am writing. Storm 2. Is it started 0th hour storm 2? No. Storm 2 delayed by 2 hours. Is not it? See here. This is storm 1 started at 0th hour. This is storm 1. This is storm 2 started at the 2nd hour. 2 hours delayed. Na 2nd hour completed. Then only storm 2 started. Same. First rainfall 2 hours. Second rainfall after completion of 2nd hour. Clearly after completion of 2nd hour. Next rainfall started. So you are delaying the values. How you are delaying the values? 0, 0, 0. Then 3rd hour discharged. Because it was started by the end of 2nd hour. Discharge value you are having by the end of 3rd hour. So 3rd hour value, what you can take? 5, 12, 25, 41. As it is. As it is, we are taking these values after delaying 2 hours. Means the 2nd hour is 0. 3rd hour gives some discharge value. We don't want remaining values because we need the only, according to question, we need only 3rd hour value. 3rd hour value. Now, by combining storm 1 and storm 2, you are having 4 hour DRH. Just add 1 and 2. Just add 1 and 2, you will get 4 hour values, 4 hour DRH values 0, 5, 12, 30, 53, 25, 41. We don't need all the values because the data question is regarding only third hour. So 4 hour DRH, because this is 1 centimeter rainfall, this is 1 centimeter rainfall. Both added 1 plus 1. Total rainfall depth 2 centimeters. Total rainfall depth is 2 centimeters. Now you convert this 2 centimeter DRH to UH. What is the formula to convert DRH to UH? DRH by effective rainfall is equal to UH. DRH by effective rainfall is equal to UH. So, first 1 centimeter, second one 1 centimeter, 1 plus 1 2 centimeter, 5 by 2, 12 by 2, 5 by 2, 2.5, 12 by 2, 6, 30 by 2, 15. This is only our answer now finally, because they are not asking all values. The question is regarding third hour value for 4 hour UH. Third hour value for 4 hour UH. The answer is this one, 15 meter cube per second. Finish, remaining not required for us. So first you are delaying that given 2 hour UH delayed by 2 hour second storm, added up 4 hour DRH, divided by 2, 4 hour UH. So what is the answer? What is the answer? 15 meter cube per second. The answer is 15 meter cube per second. That is taken. Okay? Simple. Just you need to know delaying. If you know delaying, question is completed. Second question, again related to hydrograph only. An effective rainfall of 2 hour duration. Effective rainfall of 2 hour time, 2 hour duration. Produced a flood hydrograph peak of 200 meter cube per second. Flood hydrograph discharge is given 200 meter cube per second. The flood hydrograph has a base flow of 20. Flood hydrograph carries a base flow of 20. If you know flood hydrograph discharge and base flow, you subtract base flow from it. What you are getting? You know it very well. No need to tell to you. Flood hydrograph discharge minus base flow, what is that? Direct runoff hydrograph discharge. No? So that direct runoff hydrograph discharge is 180 meter cube per second. So what you need to remember here? Direct runoff hydrograph QDRH discharge is equal to flood hydrograph QFH discharge minus base flow. QDRH discharge is equal to QFH discharge minus base flow. So we got QDRH. The spatial average rainfall in the watershed for the duration of storm 2 centimeter. For the duration of storm 2 centimeter. Precipitation is 2 centimeter. Average loss rate is 4 centimeter per hour. So consider phi value 0.4 centimeter per hour, phi value. The peak of unit hydrograph, 2 hour unit hydrograph. So if you need QUH, just now gave the formula. QUH is equal to QDRH by effective rainfall. QDRH by effective rainfall. And what is effective rainfall? Effective rainfall formula. Precipitation minus losses, phi into T. Precipitation is 2 centimeter, phi 0.2 centimeter, time is 2 hours. Given clearly. Precipitation 2 centimeter given, Phi value, loss rate 0.4 centimeter per hour given, into time 2 hours. We got effective rainfall 1.2 centimeter. Now, unit hydrograph peak discharge is equal to direct runoff hydrograph peak discharge 180, effective rainfall 1.2. What is the answer? 180 divided by 1.2. Answer is 150 meter cube per second. Unit hydrograph peak discharge 150 meter cube per second. Got it? So what is your answer? 150. Your answer is 150. Just by knowing two formula. First one QDRH, second one QH. Along with that, regularly we know formula effective rainfall is equal to P minus phi into T. You get the answer. Simple. So I will make it everything simplified for you. I hope so. Okay. So new batch of IES prelims 2021. We are ready to complete the prelims of civil engineering IES subjects in 7 months. Myself, Rajendra Prasad sir, Praveen Kulkarni sir are going to complete the subjects. I will teach environmental engineering, hydrology, irrigation, open channel flow, building materials, project management, energy and environment. RP sir will teach all structural engineering subjects, transportation engineering, survey. And Praveen sir, you know very well, he is going to teach fluid mechanics and strength of materials. So if you want to enroll for the course, take your plus subscription as early as possible using the code. Using the code, what is the code? What is the code? Tell me what is the code? Using the code KPCivil. Using the code KPCivil, join Unacademy plus subscription, you will get maximum benefits. If you don't want, no problem, you watch unlimited free lectures in Unacademy. But you inform your friends, refer your friends to take free classes, along with that plus subscription if they require. Just the only thing I need from your side, spread the code KPCivil. Spread the information. By attending these lectures, you came to know how easily I am simplifying complicated problems into simple shortcut formula. You understand how I am teaching. So that based on that you conclude easily your friends to refer to my free classes, make them to take plus subscription or yourself to take plus subscription. Use the code KPCivil. So we'll come again with another year, next year, 2016 hydrology class in the next day. Thank you, Anandal. I hope you enjoyed a lot. Bye bye, all of you.